a thing, matter, energy, force, etc. You will see mathematics everywhere. Wherever there are numbers, mathematics is there. And numbers are everywhere in the world. Therefore, we can say that the mathematics is present everywhere in the nature. Just we need to start seeing it. We need to start observing it. Right, Hetal ma'am?
Yes, absolutely, Keyuri. I agree to that.
Yeah, thank you. Now let's continue the
Uh,
planets. I will start with the planets.
Keyuri, just a minute. Can you
Yeah.
just introduce yourself once again and about the entire thing because there was some technical error. So if you could just
Okay.
introduce yourself once again.
Do you want me to start from the beginning?
Yes, yes.
Okay. So, good morning, everyone. I'm Keyuri Shah. I'm mentor of many students since many years. I have seen in and observed that every parent or every human beings in life, most of them they have the fear of mathematics, right? I want them to come out from that fear and start observing mathematics in nature. You know, mathematics is everywhere around us in our real life, and I'm going to focus on that topic today. So let's start. I'll start with the statement that the mathematics is the queen of sciences. There is mathematics everywhere in the nature. So a place, a thing, a matter, an energy, force, etc. Wherever you will see these numbers, mathematics is there. And we all know that the numbers are everywhere. And therefore, I can say that the mathematics is everywhere in the nature. Mathematics is all around us. We just need to observe it. I'll start with the first example, which is very, very fascinating, about planets. We always talk about planets. We know that the planet goes around the sun in a precise orbit. We also know that the sun goes around the universe in a precise orbit. An electron goes around the nucleus of an atom in a precise orbit. There is an order in all of this. Wherever there is an order or rhythm, there is mathematics. Mathematics is there in light. Mathematics is also there in sound. Mathematics is in order also, and it is also there in disorder also. It's just that we need to relate mathematics with our nature and with our daily life, with our regular life. Now the next question will come in your mind, that why do we learn mathematics? Why we need to force our children also to learn mathematics? You know, why, many a times the children will also ask that why we have to learn this mathematics, and what is the use of it? Is just the calculation? Mathematics generally we learn for three essential reasons. First is calculation, then application, and unfortunately, last but not the least, which is inspiration. I can say that the mathematics is science of pattern, and we study mathematics to learn how to think logically, critically, and of course, creatively. But what we learn in school is not effectively motivated. उसको इतना motivation के साथ नहीं बाहर लाया जाता है, right? And this is the concept which I want, that everybody change and everybody start taking mathematics in another way, that mathematics is useful in our daily life. It is everywhere around you. When the students ask, generally कोई बच्चा पूछता है कि why do we learn mathematics? क्यों पढ़ना है mathematics? Then the often answer given by the parents or any mentor or anybody, any person, they will just say कि we need to learn it to understand the upcoming math exam, or we need to use it for our math class, and that answer will dissatisfy the child. So I just want everybody to change their perception about mathematics. Mathematics is fun to learn. Wouldn't that will be great that we do mathematics for fun or to understand its beauty, right? Many people are not getting this opportunity that how this can happen. We don't know how to relate mathematics in our life or how it is there in our nature. So today, let me give you some simple example of mathematics in nature. Have you heard a word of tessellation? I'm sure you must have heard this word. What's it? What is tessellation? You all are using this tessellation with your child everywhere. From the child, whenever the first game when you give it to your child, or anybody to play, that is jigsaw puzzle, or maybe sometimes we give them tenagrams, or sometimes we give them a kaleidoscope to see. These all are tessellations which is present in nature. So basically, a tessellation is a pattern of a shapes that fit together with no gaps. There will be no gaps when you are arranging that shapes together, when you are fitting that shapes together. We use this, but we don't know that this is also math. We have never, inform our child that, okay, what you are playing, jigsaw puzzle, that is also a math pattern. We don't know that we are what we are seeing, the kaleidoscope is also a pattern which is a part of a math. We never relate that, but I'm sure from now knowing this, you all will start doing this. Now the question will come in your mind is that what do tessellation have to do with the nature? Then let me give you the most beautiful example. I'm sure you have seen this before, and you all know that what is it. Of course, it is a honeycomb from the beehive, a beautiful tessellation found in nature. Okay, let's see here. Here are some more tessellation which are found in nature. Tessellation can be made up of many different shapes and designs. We generally use it in our life. You can see there are four pictures. Can you guess what they might be? We are using it, we are seeing it in our daily life. Let's see. The first one is the pineapple. I do have pineapple, and you can see the tessellation, the shape of the pineapple here, which is also a common shape like honeycomb. And I'm sure you all have recognized the shape that makes a honeycomb. The second one is snake skin. The third one, you can say the outer covering of the turtle. And the last, which is commonly seen in the picture, is honeycomb. All of these shapes have one common shape, that is hexagon, and that is one common pattern which is present in nature. And we generally see it, but we never observe it, or we never relate it with the math, that okay, this is math which is present in our nature, which is all around us. Regularly, tessellations are made up of shapes that have 3, 4, or 6 sides of corners. These shapes won't overlap each other. They won't overlap each other. And as I have already informed you the definition of tessellation, that it should fit on a place without leaving any space in between. So if you see this, it doesn't have any space in between. And that is why these tessellations are very, very important in honeybee's life. What is so interesting about honeycomb, why honeycomb is, we always talk about honeycomb, that okay, it is very beautiful, why it is so important in science and math. Why do we talk about it? Is it that the bees make the hexagon shape all by themselves, and that is why we recognize it, that it is very important and interesting? Or there is something which we don't know, जो हमें पता ही नहीं है? There many times the question will come in children mind that why honeybees, they are not making honeycomb by using circles or triangles or squares. But as I said, tessellation can be made up of many different shapes whose having 3, 4, or 6 sides of corners, so they fit with each other without leaving any gaps in between, so we can use that space properly. And that is the best shape for making honeycomb is hexagon. You can try with triangle, you can try with circle. Of course, when you join two, three circles together, you will always have a gap in between, right? But when you see the structure of honeycomb, which is having a hexagon shape, you will see that there is no gap in between. Close packing is most important to maximize the use of the shape, and hexagon fits most closely together without leaving any gaps. And that is why honeybees, they generally use these hexagonal wax shapes to store their eggs, honey, or larvae. I'm sure now it is very, very clear for the students as well as for the parents or for everybody that why do honeybees make only honeycomb in hexagonal shapes or any other shapes क्यों नहीं बनाते? Because that all shapes, कोई भी shapes आप ले लो, circle या square, they will leave many gaps in between. So we have to think about the tessellation. That tessellation means the shape which fits together without leaving any gap in between, and we can use the maximize space of that structure. Okay, let me give you some more example. We generally see this all shapes, right, Hetal ma'am? We generally see this, but we never observe or we never relate it with
Absolutely, absolutely, Keyuri. I'm telling you that I myself am finding it so fascination. I mean, I'm so fascinated with listening to you. The way you are explaining, it's just excellent. The way, and you're already getting comments from people like the way you're doing the entire show is excellent. So really, very nice. I'm sure the viewers are enjoying it.
थैंक यू हेतल मैम माय ओनली मेरी तरफ से इतना है कि आई वांट देम टू स्टार्ट लविंग मैथमेटिक्स द वे आई लव
I know that.
the way
I know
I love. Yeah, okay. So let's continue with this geometrical shapes we generally we see all around us. We have observed earth many times. Of course, we have talked about a lot about honeycombs. We see mountain ranges, and we generally we often go, for the vacations, and we always see this kind of deserts, but we never relate it with the math. Let's talk about the first shape. This is a spherical shape. The earth is sphere in shape. It is the perfect shape of minimizing the pull of gravity on its outer edges. But we never think about it, right? That this is a sphere shape, which is also a part of geometry. Geometry is also a part of math, right? We have already talked about honeycomb a lot, which has the polyhedra shape, hexagon, six-sided polygons, right? Let's talk about the cone shape. Volcanoes form a cone shapes. If you can see that the fast running volcano, they forms a flatter cones, and the thick lava, they form a steep-sided cones. Cones are also 3D, three-dimensional solids, and that is also one of the cone is also one of the shape of geometry. Can anybody, Hetal ma'am, can you tell me what is in the last picture?
I think they are the marble veins or
Uh,
the
no,
wooden.
we have seen, yeah, we generally see this, but these are the dunes in Australian desert. These are
Yeah,
the
yeah.
dunes in Australian desert, which has
Oh,
this
okay.
parallel lines, though they are not exactly parallel, but you can say you can connect it, you can relate it with the parallel lines in nature, right? In mathematics, parallel lines stretch to infinity, right?
Yes.
We have seen the parallel lines of railway tracks. We see this all things around us, but we never relate it, and I want everybody to start relating it now, that the math is very everywhere around us in nature, and it is so beautiful, and we have to start loving math from now onwards. Now let's continue. One of the most important sequence which I'm going to talk about is Fibonacci sequence and golden ratio. I'm sure you all have heard about golden ratio and the beauty of it, right? So we are going to talk about the Fibonacci, who is the greatest European mathematician of middle age, and he was known as Leonardo da Pisa. He introduced this all Arabic numbers system in Europe. Of course, that system was introduced in India earlier, and then later on, he has introduced this system in Europe. Now, what is Fibonacci sequence? The sequence in which the number is a sum of two preceding number. Here you can see I have written 1, 1, 2, 3, 5. If you then add this number, you will get the next number. So we start with 0 and 1. So if you add 0 plus 1, you will have 1. Then you have 1 plus 1, you will get 2. Then you will have 1 plus 2, you will get 3. 3 plus 2, 5. 5 plus 3, 8. 8 plus 5, 13. 13 plus 8, 21. 21 plus 13, 34. 34 plus 21, 55, and the numbers goes on. Now the question comes in the mind that why are we talking about Fibonacci sequence? Is it that important? Yes, it is that important, and we can see that it is everywhere around us. I can say that I have one nose, two eyes, five fingers. 1, 2, 5. All of them are Fibonacci numbers. You can see that numbers in
Wow.
the sequence.
This I never knew, Keyuri. This is amazing. This is
Thank you. Yeah. So now let's see how this Fibonacci sequence or Fibonacci spirals comes out. You can see here in the figure, I have taken two squares of 1 by 1 first, and I place another square of 2 by 2 above it. And then next to it, the square of 3 by 3. And then 5 by 5 square. You can see that in my cursor. And next to it, I have placed here 8 by 8 square, which is giving me a big rectangular shape. Now, if you connect all the diagonal of these squares, you will have this spiral. Now, this spiral, you will see at many places around us. I will be showing you that example next to it. But before I show that example, I want you to understand that how this spirals comes out. You can take any numbers. I have just taken initial number to make this spiral or to show you, to just make it easy. You can take any Fibonacci number to make this spiral, Fibonacci spiral. Let me tell you about golden ratio also, Hetal ma'am. There are any Fibonacci number you take, you divide greater Fibonacci number by the smaller one. Yeah, let's say 13 divided by 8. You will get the answer nearly around 1.61, or you divide 5 divided by 3 or 3 divided by 2, you will always get answers nearly 1.5, 1.6, 1.61, 1.63, 1.68. So this is the golden ratio given, commonly given by this pattern. And now you will see that this golden ratio are everywhere whenever we see around us in nature. These numbers appearing in nature surprisingly often, but we never observe this. If you observe the flowers very carefully, you will always have one petal, three petals, five petals flowers, eight petals flowers, 13 petals flowers. If you don't believe me, you can take any flower and count it. I'm sure you will get a Fibonacci number. Here you can see that 1, 3, 5, 8, 13. And if you can talk about the daisy or any other number, they will also have 21, 64, something like that number. So these all numbers are Fibonacci numbers, Fibonacci sequence, which is present in nature. Now, I have already shown you the pineapple, right? If you want to see the Fibonacci number in pineapple, what you can do is you start counting the spiral of the pineapple. You will start from the down and you start counting. I'm sure you will always get a Fibonacci number. Here, if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21. So you can see that 21 is a Fibonacci number. Any spiral, if you talk about any spiral, you will always get Fibonacci number. There is Fibonacci number present in apple. Generally, we eat it, but we never observe that it is also present in apple. So whenever you cut an apple, I'm not sure that I'm going to get it in this because every apple is different. But you will always see that the sheets which we have in the apple, they are always in Fibonacci numbers. You will never have two sheets or four sheets. Either you will have three or five, or sometimes no sheets, which is zero, which is also a Fibonacci sequence. So let me just cut this and let's see if we can get a Fibonacci number of shades. You can see that there are two and one. One is present in this and two is present in this. So we have three right now in the apple, which I have cut it right now. Okay.
This
So I'm sure this
is
is
brilliant, Keyuri. This is amazing.
yeah. So Fibonacci sequence is present everywhere, Hitalman, but we never observe it. We never observe that. Okay, it is present in human body as well as. Let me give you some more example of Fibonacci sequence. It is also there in pine cones. If you see, this is the spiral which I have shown you. This is a Fibonacci spiral, right? It is always pine cones. I'm sure you all have seen the pine cones. So let's see the Fibonacci sequence in the she cells. This is a perfect Fibonacci spiral, which is there in the she cells, which is directly corresponded to the spiral found in the she cells, right? You can see here the same square which I have made or I have shown you earlier, was same to same. You can relate it here in this she cells, right? Fibonacci is also found in Mona Lisa, and that is why it is very, very famous as a perfect picture. So Fibonacci is used by many artists as well. And you can see the golden ratio over here, that is 1.6, and that is why this is one of the best, I can say, the art picture of art, right? Fibonacci sequence is also there in human body, as I have already informed you that it is present in one eye, one nose, two eyes, five fingers. Of course, if you see the bones of your hand, it is also over there. If you see your ears, their ears are always they have that Fibonacci spiral. Isn't it amazing? We always see our ears, but we never think that okay, this is also math which is present and which is already with us, right? So here I want that everybody should start seeing the nature or start observing this Fibonacci sequence everywhere. Mathematics is not just solving for x, but it is also figuring out why. Start thinking why this is like this. So use your logical mind and start thinking. I'm sure you all have enjoyed this few things which I've just tried to show you that it is also present in nature. Math is everywhere in nature, right? I'm sure Hetal ma'am, you have enjoyed this.
Oh,
um,
no, I couldn't lay my eyes off, Keyuri. I just couldn't lay my eyes off. I was really surprised to know about so much. I never knew that maths is so interesting. And you can already see the comments. There are amazing comments this time. Wonderful, wonderfully put.
Thank you,
Really.
ma'am. Now I just, at the end, I just want to give you some tips. So you can also give this to your children, or you can also use it when you are doing mathematics or when you are observing mathematics around you, that how to make it easy. You have the first tips. The first is try to understand everything logically instead of mugging up. I've seen many students or many children, they just mug up everything, even they mug up the whole sums, and they write, and if the numbers are changed, then they are confused and they won't be able to do it. I can say that mathematics is an abstract subject. You need to visualize everything when you are doing mathematics. You need to visualize that okay, this is happening, okay, this is here, teachers are talking about this triangle, the triangle, maybe Pythagoras theorem they are talking about. So where is it there in around us, are we using it? So you have to start visualizing your math, and you should never mug up. First I want everybody to understand the concept, then you have to relate them in your day-to-day life, and then you have to apply them. This is what mathematics is about. And for solving any question, The most important thing is you have to read and understand that what exactly you need, what they have asked you, and for that, reading language power is very, very important. I have seen many times the students are not focusing on language, and when it comes to relate with the word problems, they will not be able to do it. Why? Because they don't understand the language of that word problems. So you have to put more focus on reading as well, and you have to understand the language of math. And you should not rush for finding the answers. First understand what they have asked you, and then you go for the solution. That is one of the best thing, and I suggest every parent should encourage their children to read more and more. When they have that good vocabulary with them, they will be able to solve the maths easily, बहुत आसानी से कर पाएंगे अगर उनके पास language power है. So I want every parent to encourage their children to understand or read, understand the importance of reading. Second tip, I can say that interrelate all the topics that you study. You know, in maths, all topics are related to each other. They are not different. We use the triangles in many ways. We use triangles in linear equations also sometimes, or we use triangle in a normal study of triangle as well. So you have to interrelate all the topics that you study. Okay. The third one is try to understand math in your language. As I've already informed you in the first tip, that language is most important. Every student has different approach to understand math, right? Find your own way to approach math. You understand in your own language, read it, try to understand what they have asked you, and try to focus on the language, and eventually you will understand math better. Okay. The fourth one is maintain a separate book of formula list. So whenever you study, you make a separate book of it and write down all the formulas. So when you are revising it, you will it will be very easy for you to revise, right? You will never stuck up with the formula. You can just open that book and complete all the formulas, and you can just go through it once in a while in a day. The next one is each problem has one solution, but there are many ways to reach that solution, right? So we have to find out that ways. I cannot say that I can solve this sum in this way only. There are many ways in nature also which is available, and you can solve that problems by using any method. It's just that you have to reach the solution. The next one is practice as much as you can. You can practice it as much as you can. Maths is not like that you will see it, okay, I have completed, I've understood it, and then I will be able to do it. No, you have to practice it. You have to start relating it in your daily life. You have to relate it in nature. Okay, where I'm going to use this, and you have to the as much as you practiced more, you will be able to solve, and you will be get starting, you will start loving math when you practice more and more. And the last one I can say is review errors. Whatever errors you are making, do not ignore it. You have to review all that errors. Okay, this is where I have made mistake, and try to solve it next time. Lastly, I will conclude my session by saying that mathematics is everywhere in the universe. We seldom note it. We enjoy nature and are not interested in going deep about what mathematical idea is it. Mathematics express itself everywhere in almost every facet of life and in nature all around us. So start seeing mathematics everywhere in nature. I hope you all have enjoyed my session, and the Hetal ma'am, over to you.
Yes, yes. Keyuri, you can stop sharing. Yes, now you are on screen. Very nicely done, Keyuri. It was an amazing session, and you are going to love the comments which have come for you. in the comment box. I have displayed all of them for the audience to read, and it was an amazing session. Could you just explain what is coming up next so that they are all excited for the next session also?
Of course, the next topic is same only, but I'm going to start with some hands-on activity, which is all which you can see in nature, but we never observe it. We just see it. So we are going to do that hands-on activity, and of course, some more interesting fact about maths in nature on the higher level. This is just a basic what we have discussed today. So I'm going to take it on more higher level, and I'm sure everybody will be there with me for the next session. And I hope you all have enjoyed this session.
I'm sure they have enjoyed. You have got a lot of thank yous, and they are sharing their gratitude also. And so, audience, this was a wonderful session by Keyuri, and we are going to have another rocking session by her this month, which is going to come in the last week of December.
December.
So stay tuned for the Learning Cafe by Keyuri, and thanks a lot, Keyuri. You can bid the audience goodbye.
Thank you. Goodbye, everyone. See you in the next session. Thank
Thank
you.
you.